Okay, so now that we've gone over the anatomy and the pathway of blood, hopefully you have a great understanding of that. We're going to take it a step further and we're going to talk about the function, and we're also going to talk about heart sounds. So when you're listening, what are you hearing? And then talk about factors. So how your daily life can impact how the heart functions. So body pumps 6 quarts of blood through the blood vessels 1,000 times a day. If you see here, these are each a quart. So imagine this going around in your body, all like from your heart back to your heart, 1,000 times in a day. And we'll talk about how, because it's a lot of fluid. So this here is a cardiac cell, branched, striated, uninucleated, and it contains intercalated discs. Unlike skeletal cells, they will contract spontaneously and independently. That's what makes it involuntary. Even if the nervous connections are severed, the heart could pump by itself. Have you ever seen those crazy movies where they pull the heart out, or like the heart's out in someone's hand and it's still beating? That is because it has its own intrinsic conductive system, which we'll talk about in a minute. Atrial cells, your atrium will contract 60 times in a minute, and your ventricle will contract about 20 to 40 times per minute, depending on exercise and things like that. So there are 2 types of heart activity systems. They act to regulate your heart activity. The first one is, we learned in Unit 3, it's the ANS, autonomic nervous system. Decreased heart rate specifically would be parasympathetic, but as you know, during sympathetic fight or flight, it would be the opposite. It would increase, right? Because you're trying to fight or flight. But today's focus is going to be on this intrinsic, means inside, conductive and nodal system. So that's what the focus will be now. It's built within your heart tissue. It sets a basic rhythm, as you know. If you're listening to the heartbeat, there's a rhythm to it. It's composed of special tissue that's found nowhere else in the body. It's a mix between muscle and nervous tissue. This system causes depolarization into one direction, which would be from the atrium into the ventricles. Not the opposite, but always depolarization will go atrium to ventricle. In other words, atrium contracts, causing the ventricle to contract. It will enforce a 25 beat per minute. Make sure you know that that's how many beats you should have in a minute without exercise or anything else. That's average. So this is what ANS and the nodal system working together would look like. You have your medulla oblongata. That'd be like your vagus nerve during parasympathetic. For sympathetic, it was T1 through T4, T1 through L2, but specifically for the heart, it's T1 through T4. So these are the ones that are specific towards the heart. So during parasympathetic, the medulla oblongata and the vagus nerve would attach to your nodal system. And then when you're in sympathetic fight or flight, that would shut off, and then you would go to the T1 through T4, and then it would increase the heart rate here. Okay, so now that was a review of ANS, but we're talking mostly about nodal. So intrinsic, conductive system, and nodal system. So the first structure is called the SA node. That's your pacemaker. It's in your right atrium and will set the pace. I gave you guys a diagram, so if you want to look down now and highlight that, that's a good idea. Sinoatrial node, that's in the atrium. The right atrium to be exact. But when it's depolarizing, it will cause both the right and the left atrium to contract. Your AV node is in junction of the atrium and ventricle. It will be the beginning of the contraction of your ventricles. Your AV bundle, it has 2 branches, a right and a left one, located in the interventricular system. And then you have Purkinje fibers. They spread within the muscle of the ventricle walls. When depolarization is occurring in any of these structures, that's when it's contracting. So this is the diagram I provided for you. This has Purkinje fibers, and my face is obstructing your view. This is your SA node here, AV node, AV bundle, AV branches, and these are your Purkinje fibers here. Depolarization, when it goes from here to here, the atriums are contracting. When it's going from here to here, your ventricles are starting to contract, but the big contraction will be up in the Purkinje fibers. When it goes through the Purkinje fibers, it will cause your ventricles to contract from the apex up, making the blood push either from the left ventricle out the aorta or from the right ventricle out of your pulmonary arteries. As you can see, it's pushing in that direction. So this is how the basic rhythm will occur. Your SA node has the highest rate of depolarization because it's first. It starts each heartbeat and sets the pace. That's why it's called the pacemaker. From the SA node, the impulse will spread through the atrium to the AV node. This impulse is delayed briefly to give the atrium time to contract. So from the SA node to the AV node, it will stop for a second as the atrium is contracting to get the blood from the atrium through your AV valves into your ventricles. The impulse passes rapidly through the AV bundle. So that bundle that I showed you in between the ventricles, that's fast. But really what's going to happen, the Purkinje fibers will get this ringing contraction of the ventricles that begins at the apex and moves towards the atrium, pushing the blood up and out of your arteries. Let me get this out of your way. Actually, I'll just get my face off. This contraction effectively ejects blood superiorly into large arteries, leaving the heart. So just what I said before. So SA node to AV node, there's like a pause. This is all depolarization. That means, remember, depolarization is sodium going in, causing that upset. Then really the AV bundle's fast. It gets right through there, but it's going to slow down to the Purkinje fibers to push the blood out the arteries, up and out. Okay, so sometimes this is just a picture here to show you sometimes a pacemaker will be put in to control your nodes, and it will be able to do that because there's something wrong with your intrinsic conductive system. Okay, so cycle and sound. So to start, the atrium contracts simultaneously. As they start to relax, contraction of the ventricles will begin. Systole means that the contraction, so anytime you hear systole, that means ventricles are contracting. Diastole means relaxation of the ventricles. So when depolarization is occurring in the atrium, the ventricles aren't in diastolic, right? Because the atrium's contracting. When the atrium's contracting, ventricles are relaxing. You don't want them contracting really at the same time. When the ventricles are contracting, it's in systole. Average heartbeat is about 75 times per minute, so the length of each cycle is about 0.08 seconds. Okay, so sound. So what are you listening to? When using a stethoscope, you can hear two distinct sounds during this cardiac cycle. They're seen as lub-dub. The first is longer and louder, and the second is short and sharp. So lub-dub. First heart sound is caused by the closing of the AV valve. So that's the closing of your tricuspid and bicuspid valve. The second heart sound is caused by the semilunar valves and the end of systole. So that's the closing of your pulmonary valve and your aortic valve. Now that you know a little bit more about how the contraction occurs in systole and diastolic, we're going to talk about factors. So one complete heartbeat is called a cardiac cycle. We just talked about this as review. The contraction of a heart chamber is called systole, and the relaxation of the chamber is called diastole. If they do not specify, you just figure they're talking about the ventricles. This is just talking about the bicuspid and tricuspid. We'll just skip through this one. Okay, blood pressure is the force of blood against the walls of the arteries. Blood pressure is recorded as two numbers, the systolic pressure over the diastolic pressure. So in other words, what is the pressure against the arteries when it is in systole versus diastolic? The average blood pressure should be around 120/80. This number does vary from person to person, so you should know what your normal is. The instrument to measure your blood pressure is called a sphygmomanometer. It is measured in millimeters of mercury. Factors that affect that 120/80 can be like cardiac output, so stroke volume times the heart rate. Blood volume, you should have about 5 liters per average adult, but maybe you have more or less. You could have like internal bleeding or something, that's something the doctor could see. Like if your blood pressure was low, for instance, that could be a sign. Blood viscosity, so the thickness of your blood. If you're dehydrated, you may have a thicker, slower moving blood system. You want to make sure you're hydrated. And what we'll talk more about is peripheral resistance. So that means something is blocking the pathway of blood. Plaque. That is something that can build due to a high saturated fat diet, or a high saturated fat diet combined with a high sugar or carb diet, and lack of exercise. So fatty substance that blocks off coronary arteries. Your coronary artery is the major artery that will oxygenate your heart. If the oxygenated blood cannot reach that part of the heart, it will start to die. It's a cell. Death of the heart equals heart attack. This is what it would look like. So this would be like a start of a plaque buildup. It's very sticky, so once it begins, plaque will just build upon itself. Inflammation will occur, rupturing will occur, and eventually it will completely block that part of the heart and it will not get enough oxygen. So this is what that would look like. This would be like dead heart muscle. So the actual disease itself is called atherosclerosis. Deposits of fatty material such as cholesterol form a plaque in the arteries, which reduces blood flow. It also can be called arterial sclerosis. It could be either one. One treatment is called an angioplasty. It's when they put a catheter in. So they'll put it in with a balloon, blow it up, and it will increase the amount of surface area there that the blood can pass through. This is a temporary fix. A lifetime fix would be diet change. Hypertension can occur from this. So if it's being blocked, blood can't get through, and it could cause something called an aneurysm. But hypertension, so it's high blood pressure, the force within the arteries is too high, so your sphygomanometer could read above 140/90. So that's saying that the ventricles are contracting a lot, trying to push the blood through. Something is blocking it. An aneurysm is when a bulge would occur, and it could cause an aneurysm in the brain. So internal bleeding can occur because it can actually rupture. It'll get very large and actually explode out. Hypotension is anything that's less than 90/60. Here's like a chart to kind of show you. So remember, normal was 120/80. This is still kind of, I mean, you could just have eaten bad over the weekend or something, and you can have these numbers. But when you're in these range here, you're in high blood pressure. So if 140/90 and above, 180/110, you need to get on medication. So the mitral, so these have nothing to do with plaque. This is just maybe something you're born with or something that occurs. NVP is called mitral valve prolapse. So one of your valves got out of place in the bicuspid valves. This will create a clicking sound. So when you're listening with the sphygomanometer, when you're listening in, not the blood pressure cuffs, but when you're just listening in, you would actually hear this, but instead of the lub-dub, you would hear an extra sound. Heart murmurs is another. It could be caused by MVP, so it could go together, but that means something is causing a difference in noise, whatever that may be. So a heart murmur, murmurs range from faint to very loud. It could be a swishing sound. It may or may not be a valve problem. It just depends on what it is. This is what open heart surgery would look like, just by the way. And I believe that is it. So thank you very much. I'll see you next time.